Have you ever heard of the word fuzzing? Obviously not. Now, fuzzing is a software testing technique that involves providing invalid, unexpected, or random data as input to a computer program. Now, what does this mean? Come with me, I'm going to explain. Imagine a vending machine, and to get the machine to dispense a product to you, you would need to insert a valid coin. Now, fuzzing is you trying to insert random objects into the coin slot. You might also press some random combinations on the button. Now, the goal would be to find out what happens when the machine receives unexpected input. Now, for example, does the machine jam? Does it display an error message? Does it dispense an unexpected project? By subjecting the vending machine to these unusual inputs, you can identify the potential weakness or vulnerabilities of the machine. Similarly, fuzzing software aims to find unexpected behaviors or security holes in a program by providing it with invalid or random data. Now, in the Web3 ecosystem, if errors like this go unnoticed in projects, it could result to a loss of funds and other consequences. A vivid example was the massive hack that led to the loss of $60 million worth of Ether on the Ethereum blockchain, a tiny block in the DAO smart contract code. This allowed an hacker to exploit the weakness and steal millions from investors. So in this video today, I will be introducing you to Trident, a specific tool that uses fuzz testing to test Solana programs. Trident is the first open source fuzzer for Solana programs written in Anchor. It is a Rust-based framework to fuzz and integrate test Solana programs to help developers ship secure code to the blockchain. It was created by Aki Blockchain, backed by the Solana Foundation to make testing easier and to help developers find trickier bugs that might otherwise go unnoticed. Now, Trident has been around since 2021. It was first called Trident. It gained a lot of attention after winning the Marinda Finance Community Prize at the Solana Reputed hackathon in 2022. Last year, 2023, Trident got a development grant from the Solana Foundation, highlighting its important place in the Solana ecosystem. Now, Trident has 4 major features that makes the project or the tool stand out. The very first is automated force testing generation. Now, what does this do? Trident automatically creates test templates for programs written with Anchor, saving developers the time and the effort. Now, why is this helpful? It means that developers spend less time setting up tests and more time actually writing the code, making the development process more efficient. The second feature is the adaptive input. What it does is Trident generates changing inputs to test the program in different ways, helping to find hidden bug. And why is this helpful as well? By testing with a wide range of scenarios, Trident can uncover issues that might not be obvious. The third feature is guided instruction sequence. What does this do? Developers can set up specific sequences of instructions to test particular parts of their code more effectively. And now, why is this helpful? This gives developers control over which parts of the code to focus on, allowing them to identify and fix problems more precisely. Now, the final feature is invariant checks. Trident allows developers to add checks that help identify vulnerabilities and unwanted behaviors in their programs. And why is it helpful? By catching potential issues early, developers can fix them before they turn into big security risks. So how do you get started with Trident? Firstly, you need to set up the environment to work with Solana programs written in Anchor, which would require you to install the necessary dependencies, which includes Rust, obviously, because Solana programs are built on Rust, Solana 2 Suite, Anchor, and ongoing Fuzz RS for Fuzz testing, and then running the fuzzer against sample Solana programs to observe its behavior and results. So I ran a few tests myself, and I observed that Trident was able to identify several edge cases and potential vulnerabilities. It effectively stimulated the numerous scenarios that could cause unexpected behaviors in the program. The output logs themselves were detailed, providing me insight into where and why the programs would or should fail. And obviously, from these cited errors, I was able to review the issues highlighted by Trident, which included input validation errors and potential security flaws. I made necessary modifications to the Solana program to address these issues. We ran Trident to confirm that the vulnerabilities were actually resolved and to ensure that no issues were introduced. I am OJ, your Web3 Fanboy content creator. See you guys next time. Bye.